Good afternoon. Now we will go with more one type as I mentioned in last. In last video we are with x, sin x, cos x. Now in this we are going to change it and we are going to make it as x to the power m, sin x and x to the power m, cos x. So x and x to the power m, we have different one. Now you can see this. So this we have as usual. So m x to the power m sin ax. Now this sin ax we have to write as e to the power iax. So we have e to the power iax, and that is cos x, cos ax plus sin ax. So e to the power iax we have equal to cos ax plus sin ax plus I sin ax. So whenever we have sin ax, we have to consider imaginary part of this. So you can see, so we have this as imaginary part. So we have to deal with I part only, not real part. And when we are with cos ax, so you can see on this side, so we have here cos ax, and then when we have cos ax, we have to consider it as a real part. So whenever cos ax, we have to go for real part. Whenever sin ax, we have to go for imaginary part. So here I have mentioned a real part of this. So now we will solve one example and then you are going to understand what a real part and what imaginary part. So now we will have example d square plus 1y. So we have d square plus 1y and that is equal to x square and sine 2x. Now, first we have to go, that is auxiliary equation for complementary function, and then we have auxiliary equation we have for this d square. Now we have tried m square plus 1 equal to 0, and therefore we have m square equal to minus 1. So we have m square equal to, or m I will write directly, plus minus I. So real part is 0. So we are not going to get anything with the real part. We are direct imaginary part, and therefore we have yc that is equal to e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. And now you can see in this, we have alpha plus minus I beta. Now alpha we have 0 and beta we have 1. And therefore this e to the power 0 x in bracket c1 cos x, because beta is 1, plus c2 sin x. And from this we will get yc that is equal to complementary function we have c1 cos x plus c2 sin x. So this is our complementary function. Now we will go for imaginary, for particular integral. So we have now particular integral. So we have q, we have 1 upon, we can say, d square plus 1, and that is into x square into sine 2x. Now sine 2x I can write it as, just we have seen, that is imaginary part we will say, or I will write there 1 upon d square plus 1 into x square into imaginary part of e to the power iax, a is 2, so I 2x. Now we know rule, that is e to the power ax into x to the power m, and in that case we can have, so if we have 1 upon d square plus 1, then we can have this e raised to ax into 1 upon d plus a whole square into x square. And the same rule we will apply here. We have value of a is I2 or 2i we can say, and therefore we have particular integral, that is yp equal to, we can write it as imaginary part of e raised to I2x into 1 upon, now d square, so we have d plus 2i whole square plus 1 into x square. And then we have yp, that is equal to imaginary part of ei2x into 1 upon, we have d plus 2i, so d square plus 4id and 2i square, so it becomes minus 4 into x square. And for x we know we have to make it in 1 plus x form, so ip e raised to I2x, and then we have to take d square plus 1, so minus 4, and we have this as plus 1. So minus 4 plus 1, this becomes actually minus 3. So we have 1 upon d square plus 4id minus 3. So here square of this we have d square plus 4id plus 4i square. I square is minus 1, so minus 4, and this one we have as it is. Now we have to take minus 3 outside. And then from this we will get equal to ip minus e raised to I2x upon 3. And then we have, I will directly write, this will be 1. Now these two term becomes minus, so minus d square plus 4id upon 3 to the power minus 1 into x square. So we are being in this fashion. Now we have this as minus, this as minus, so it will be plus. We have to consider it as plus. And now we will go for this yp, and that is equal to minus e raised to I2x upon 3 in bracket 1. Then we have all terms plus, plus we have d square plus 4id upon 3 plus d square plus 4id upon 3 whole square. This is more than sufficient because we have term as x square only. Now in this we can have, if we will go square, then d square we do not have, so that we need not require. Or if we will go square of this, then we have d4 plus 28id cube, and then plus, so minus 16d square. So these two terms will not be considered because derivative of x square, if we will go twice, so that already we have seen d of x square we have 2x, and d square of x square we have 2, and onwards we have d cube of x square we have 0, and so on. So we will consider d square only, and then we have yp, that is equal to minus e raised to I2x upon 3 in bracket 1 plus, now separate out it, d square upon 3 plus 4id upon 3, and then remaining we have this part. So we have square of 3 because we have this bracket square. So it goes to minus 16 by 9. Actually, it is 9 below all terms, but first two terms will not be there. And then we have minus 16 by 9 d square into x square. And then multiply by x square and put a relative term d of x square 2x and d square of x square 2. So from this we will get equal to minus e I 2x upon 3 in bracket we have x square. Now d square we have 2, so plus 2 by 3. Then d we have 2x, so we have plus 2 8x I by 3. And then d square we have 2 minus 32 by 9. And now these 2 by 3 and minus 32 by 9, if we will solve this, we have e to the power minus I 2x upon 3 in bracket x square plus 8x I by 3. And then we have minus 3 3s are 9, so 3 2s are 6. 32 minus 6, 26. So 26 by 9. And this is again we have clear. We have to consider imaginary part. So IP, this is most important. Imaginary part we have to consider. And now we will write it. So we have equal to, this is minus sign over here. So minus 1 by 3. And then we have cos 2x plus I sine 2x. And then we have this will be as it is x square plus 8xi by 3 minus 26 by 9. So this we can make actually in this also imaginary and a real part different. So we have x square minus x square minus 26 by 9. So we have this as imaginary part, and then, sorry, real part. And imaginary part we have 8x by 3i. And then we will multiply it. If we will multiply by cos 2x, then we have minus 1 by 3. So this actually we can directly write cos 2x, and this value we will get it as real part. We are not interested with real part. So we are interested with imaginary part. So directly we will consider the part which are with I. So we have minus 1 by 3. And then we have 8x by 3 into cos 2x, because that is with I. Without I, we are not going to consider. And then I sine 2x, if multiply with this, then again we have this as imaginary part. So we have plus x square minus 26 by 9 into sine 2x. Now, if we will multiply I sine 2x with this, then this I square minus 1, and that becomes again real part. So we have yp, we have this value. And then we can write that is solution, that is yc plus yp, and therefore we have solution of this. So y equal to yc plus yp, and from this we can write y equal to c1 cos x plus c2 sin x. This is complementary function. And then we have minus 1 by 3 in bracket 8x by 3 cos 2x plus x square minus 26 by 9 into sine 2x. And then from this, we will have solution for the given differential equation. So I always mention, try to write answers of any subject in block, so examiner can check it very fast. So now we will stop here only. Thank you.